The HARC EFD Coastal Impacts Technology Program focuses on research, demonstration, and workforce development to address environmental issues associated with petroleum exploration and production activities along the Texas Gulf Coast. There are 14 projects being conducted in various conservation and research topics important to the Texas coastal region. These projects fall into 4 categories of study: site restoration, air emissions, water, and workforce development. Each project was designed to mitigate impacts of oil and gas exploration and production in coastal areas. In this video, we will see several of these projects being conducted at Texas A&M University Kingsville. They include air emissions, biological treatment of volatile organic compounds in air emissions. Dr. Kim David Jones, Principal Investigator, Department of Environmental Engineering. Dr. Jones is conducting research on biological treatment of air emissions as a cost-effective and sustainable alternative to high-temperature thermal oxidizers or flares. His goal is to find new ways of removing hazardous air pollutants and volatile organic compounds commonly associated with oil and gas production. Site restoration. Effects of age and depth on topsoil properties and seed banks characteristics. Dr. David B. Wester, Principal Investigator, Caesar Kleberg Wildlife Research Institute. Dr. Wester is the Principal Investigator on 2 projects aimed at improving site restoration practices. One study involves the effects associated with the common practice of stockpiling topsoil stripped from drilling pads and pipeline rights-of-way for later use in site restoration. This practice of stockpiling changes the chemical and biological properties of the soil and seed banks in ways that can strongly influence the success of subsequent site restoration efforts. Dr. Wester and his colleagues are studying soil properties with the goal of improving soil storage practices through better understanding of relevant ecosystem processes. Information obtained in this study will be used to develop recommendations for greater success in site restoration. Restoration of soil mixtures. Dr. David B. Wester, Principal Investigator. The second study focuses on ways in which surface soils that are disturbed and mixed with subsoils as a result of pad or pipeline construction can be restored to health for greater success in site restoration. This study examines seed germination and seedling establishment in response to growth medium manipulation and the use of soil amendments. In combination with these soil cultural practices, greenhouse and field studies are exploring which native plant species are best suited for use in site restoration. Air emissions. Thermal swing adsorption to capture toxic air emissions from point sources. Dr. David Ramirez, Principal Investigator, Department of Environmental Engineering. By capturing and recovering toxic air emissions from point sources such as oil and condensate storage tank vents, Dr. Ramirez is developing and testing an innovative thermal swing adsorption system, TSA. The system makes use of commercially available granular activated carbon, GAC, as a media to passively capture gas emissions. The study focuses on the capture of volatile organic compounds, VOCs, in both gaseous and liquid forms. Electrothermal heating integrated with the system functions to desorb or release the captured compounds for treatment, disposal, or reuse. Water. Assessment of 2 alternative smart shale fracturing fluids, desalination concentrate, and CO2 foam. Dr. Lee Clapp, Principal Investigator, Department of Environmental Engineering. Drilling and hydraulic fracturing requires large volumes of water. The Eagle Ford Shale region is experiencing a drought during a time when this additional water is needed. Dr. Clapp's work involves research in 2 alternatives to the use of highly valued fresh water in hydraulic fracturing operations. The first concept under study involves using brine produced from desalination of brackish groundwater or treated flowback water. In a second part of the study, the feasibility of using nanoparticle stabilized carbon dioxide foam as an alternative to water for hydraulic fracturing is also being investigated. These studies have the potential to reduce the environmental impacts of petroleum exploration and production activities along the Texas Gulf Coast. In the videos that follow, each scientist will tell us more about their work and the results of their studies to date. If you would like to know more about the EFD program or about any of these studies, please call or email us at www.efdsystems.org or call us at 281-364-6093.